Characterizing Patna's urban air quality and assessing opportunities for policy intervention. This study was conducted in 2014. Full report is available at urbanemissions.info. In this video, we explain how the similar family of tools were applied to do the air quality analysis for the greater Patna region. So we put together an emissions inventory of all the known sources in the region, did some dispersion modeling, health impacts, and scenario analysis for 6 interventions which were discussed with the Bihar Pollution Control Board. These are the key data sources that are available from various ministries. We have the population census data, which has information on population at the district level by age group, and also information on the residential fuel consumption. And we have the Ministry of Road Transport and Highways has details of registered number of vehicles in the city and the district and in the state, and also some surveys on what is the vehicle density on various roads in the cities. We have the Central Electoral Authority, which has information on various power plants in the region, their capacities, and different types of control equipment installed. And we have the Ministry of Statistics and Program Implementation. They have information on all the industries which are registered in each of the districts. At the district level, we have the industrial fuel consumption by coal, gas, and liquid fuels, and electricity consumed in various industries that is used as a proxy for building an industrial emissions inventory for the region. This is the Greater Patna region, about 60 by 30 kilometer region. We have also mapped out the brick kilns in the region. This is the main urban area. There are about 100 stacks here, about 50 stacks here, and about 75 stacks very close to the city region. These brick kilns are seasonal in operations. All of them use fixed chimney brick kiln technology. The vehicle fleet majority is motorcycles, followed by cars, autos, and a certain number of trucks. These trucks are registered in the Bihar state, but there are a lot of trucks that pass through the state because this is part of the Indo-Gangetic commercial corridor. Diffuse area sources, a lot of domestic sources still use coal and biomass for cooking and heating, so an inventory was put together for that. Overall emission inventory would look something like this for 2012. So we looked at all the criteria pollutants: PM2.5, PM10, SO2, NOx, CO, VOCs, and CO2. More details on how these inventories are put together will be explained in the following video with more details on each of the sectors. Projected emissions would look something like this for PM2.5. This is for PM10. One major sector which is much different from PM2.5 is the road dust. For SO2, the brick kiln sector is one of the increasing sector industries. The industrial growth is expected to be at least 6 or 7% in the coming years. Then you have your carbon monoxide emissions, a majority of them coming from the transport sector. And using a number of spatial proxies which are discussed in the similar tools, we have a spatial distribution of these emissions for each of the sectors. If we sum up all the emissions in the main city area, it would look something like this for PM10. 30% coming from road dust, transportation sector, domestic cooking and heating, open waste burning, construction activities, industries, and brick kilns. So this brick kiln part looks very small because majority of the brick kilns are just outside the urban area. If we increase that domain to a slightly bigger area, there you will see start including more of the brick kilns into the inventory. If we go to the northwest region, majority of the emissions are brick kilns. Same thing if you go to the southeast region, we have majority of the emissions are from brick kilns. Meteorological data is extracted from the NCEP reanalysis fields. This is a global database. So we have the annual precipitation patterns, wind speeds at the ground level, and also looking at the mixing heights. Combining the emissions and meteorological data, we have the dispersion patterns. We have done some calibration of these of the model concentrations, 2 of the stations which are in the city region, within the city, and also looking at the seasonal pattern of these concentrations. We have a lot of rain in the summer months here, So you have very low concentrations, but the winter time the brick production and industries are at the peak. They do contribute a lot to the total emissions. Using the global burden of disease assessments methodology, we've done the health impact assessment for base year and for the projected years. For 2012, we have 2,600 premature deaths, and under business as usual scenario for 2030, it would go up to 4,900. We looked at 6 different scenarios for brick kilns, introducing zigzag technology in the brick kilns, and also including relocation of some of these clusters here. Introducing Bharat 4 standards, improving the public transportation system, abolishing the diesel generator sets in the city area. This is assuming that the coal-fired power plant, which is coming up about 100 kilometers away from the city at Bar, would result in abolishing the use of diesel generator sets, controlling road dust, and all combined. If all these interventions are actually introduced by 2030, we could expect a 30% drop in the total concentrations and a 30% drop in the total health impacts as well. Full report is available on the website, where more details on the inventory, the meteorology, and the results are explained in detail.